You're on. Can you share your screen, Rick?
Rick, can you hear us?
Okay. You ready to go?
We're good to go.
We can't hear you, Rick. Rick can't hear us either.
He's muted.
Unmute.
Okay. You're muted. Rick, you're muted. You good? No. No. Oh, but can you hear us?
Rick can't hear us. We can't hear
Yes, yes, I can hear you.
Yeah. Rick, you're muted.
Okay.
Nice.
It should work now, but the presentation screen's gone gray. What's the trick on this?
Oh, that's fine. We can see it.
We can see your slides though.
Yeah, we can see your slides.
Okay, you can see that now, and you can hear me as well. All right.
Perfect.
I'll leave it small. I did put the URL on the general section of Discord, so you can look at them later if you can't read them this way. Basically, it was kind of an interesting trip. I don't know if it'll ever end up in a FreeBSD release. That probably depends a lot on whether others start implementing stuff related to directory delegations. It's kind of an interesting challenge. I can't say at this point whether it's worth the effort. I'll get to that at the end. Right now, I only do monotonically increasing directory offset cookies, and you'll see later, at least for the client side, it's not going to be easy to do the others. I don't know how these things usually work, but if you ever want to ask questions, just yell. Okay, maybe I have to do it here. Oh, great. Now, how do I get it to the next slide? Usually I just click here. No. What's the trick here? Okay, for some reason, I'm not able to move to the next slide. I have. Normally, I just click here.
If you have a PDF version of the slides, we can display those instead of the open office.
Well, yeah. Sorry, I'm not sure how to get past here. Damn it. If you guys have the slides, I can pull them up on another screen.
How do I share my screen?
Talk.
You go button at the bottom to share screen. Full screen.
Breakout rooms, polls, QA, recording, transcripts, whiteboard. Yeah. Troubleshooting of use. Turn on captions, apply.
Let's see, what can I do over here?
Oh, there it is.
Oh,
Yeah, that's it.
They have to get rid of stop sharing his on there.
oh, okay. All right. So if you can flip through them, I can talk. So you flip to the next one.
Will do.
All right. So a few things that came in handy for FreeBSD specifics. I don't know what other systems like Linux has. Something called Event Handler, and I see I misspelled it. Basically, all that is that it allows you to put macros in any place in the kernel, and it calls a function that's registered against it. So basically, you can stick the event handler macros inside the file system code, and then the NFS server gets called. A second one called task queue is just an easy way to hand work off to a kernel thread for asynchronous execution. It comes in handy. And the final thing for the client is that the normal way FreeBSD handles it is 8K blocks for NFS directories, and they can be searched efficiently by any 64-bit key. Obviously, in this case, the 64-bit key is a directory offset cookie. The nice thing is the key can be exact match, or it can be less than or equal. The latter comes in very handy. Want to go on to the next one? Okay, this probably isn't easy to see, but talking a little bit about the way I did it on the server. Basically, I have a hash table hashed on file handle. That's that vertical thing down the left side. And then I hang the various entries for the directory delegations off it by basically feed on file handle. And basically, the multiple ones for the same file handle end up adjacent to each other. That just is a slight optimization because, of course, in directory delegations, multiple clients can have a delegation for the same directory at the same time. And that's just the data structure I use to keep track of them on the server, and it seems to work pretty efficiently. In general, you'll find that to make this useful, you have to get the CB notify callbacks to go efficiently. Can you go on to the next slide? Okay, so now you have to generate these notifies. Essentially what I did was I stuck the event handler calls inside UFS. I've only done UFS so far. And basically, the trick is to find the right place. In UFS, it was actually fairly easy. There's one called UFS dir enter and one called UFS dir remove, which pretty much is in the right spot, with a couple of limitations. One is you have to be careful to do it at a place where the attributes for the directory have been updated, because you need the up-to-date attributes for the CB notifies. And another factor is, in my case, you can't tell the difference between a remove and a rename. And for the add, you can't tell what the previous entry is. That's a big limitation on what I did. Basically, to get the previous entry for the adds would have been a lot of work, because sometimes they're right in front of it, but in the directory, sometimes they're in a previous block. And it would have been a lot of effort in the file system to go back there and look. The good news is when you're monotonically increasing directory offset cookies, you don't need the previous one. The not so good thing is the RFC says that you're pretty much supposed to generate it except when you're at the beginning of the directory. So I cheated a little bit on what the RFC said. Any questions? I can go on to the next slide. So a few things that might interest other people, interesting things that I didn't expect to be awkward, but were. Directory offset cookie becomes a real bother sometimes, because it doesn't really refer to a fixed location in the directory. For example, the directory you're looking at, it refers to foo. But if you delete foo, then it refers to bar. What it really does is it refers to the first entry after ... And that changes dynamically, and you end up writing special cases in the code, at least I did, to deal with that pretty much everywhere you bump into it.
I have a question.
Yeah.
Are you talking about the cookies generated by your file system, UFS, or are you talking about the protocol, the NFS protocol?
They're one and the same. In the case of FreeBSD, the file system generates the directory offset cookie. And then for the most part, the NFS server just spews it out to the client. Directory offset 0 is a special case because in most file systems in FreeBSD, dot and dot, offset 0 would be dot, or may not even mean any entry. So
This is
does that answer
particular
your
to
question?
UFS? No, I'm trying to understand if cookie 0 means something special only for UFS, or is it, because on Linux, I don't think we don't behave this way.
Well, in NFS, 0
Not
refers
saying it's
to
right or
being
wrong,
a
but-
directory. And of course, the difference is for 3, it refers typically to dot. For 4, it refers to the first entry after dot dot.
Right, right.
For UFS, what I was doing, 0 would refer to dot. Does that answer your question enough?
Yeah.
So you would just add a little offset to the cookie, I guess, before you send it out.
Yeah. So basically, for offset cookie 0, you end up having to do something special because you have to find the
I
first
see.
entry after dot dot and not just whatever the file system thinks is 0.
Got it.
Does that make sense?
Yes. Thank you.
Okay.
Mhm.
You can pop on to the next slide if you want. Okay, so this is another one I bumped into. readdir in UFS on FreeBSD was a little bit sketchy. What it would do is it would return the directory offset cookie of the next entry, but sometimes those entries aren't valid entries. The way UFS works, of course, is when something's removed, it marks the entry invalid. Sometimes it absorbs it by extending the direct length of the previous entry. Sometimes it marks the d_inode or d_file node to 0. And what would happen, and does happen right now for FreeBSD server, is it'll return an offset for one of these invalid entries. It doesn't matter for readdir because readdir just skips over them and continues on to where there's a good entry. But it's not good enough for CB notify remove entry because it needs the actual cookie of the valid entry, not the invalid entry that precedes it. Does that all kind of make sense?
Yeah.
Okay. So that's another one I ran into, and I fixed it by doing a couple of things. One is I started to change UFS readdir to return the current entry, the cookie for the entry, and not the next one. I ran into this in a number of places. I kept finding that the directory offset cookie for the next one wasn't what I wanted. I wanted the current one. So what I ended up doing is changing UFS so it returned the cookie for the current entry, not the next one. And that made it a lot easier in the server. And of course, the server still has to return the next one for readdir, but that's just shifting one element down the list or array. So maybe you can flip on to the next one if there's no questions. Thank you. So, but they provide the current entry quite conveniently, but they don't provide the previous entry easily. I said this already. Basically, sometimes it's right in front of it, but sometimes it's in a previous block and it's really hard to get at. So I just don't bother returning the previous entry. And that's cheating on the RFC, but for monotonically increasing cookies, you don't need the previous entry. You can always use the cookie to figure out where it goes when you add it. So I didn't bother to generate it. For renames, there's a bit of a similar story in that I don't know when a remove and an add is happening because it's a rename, or a remove and an add is happening because of something else, like a remove or a create. So I never generate the callback for rename. And I'm not yet sure if you ever need it. My current code has a little bit of a problem with rename, but I haven't figured out where the bug is. So I'm not sure if I have to someday try and figure out how to generate the rename case specifically. To do it would require a lot more intervention in the file system, and the FreeBSD people won't be excited by any intervention into the file systems. They care much more about UFS and ZFS than NFS. So the less I need to do in the file systems, the better. That all makes sense? On to the next slide, I guess. Okay. Now we get into things that are sort of more things I haven't been able to answer yet, which are the interesting stuff. When should you do it? Right now, my server never does a CB recall. It did get settled, I think, on the IATF mailing list recently that you can do a CB recall for directory delegations. There's one place in the RFC that suggests it's not the case because it suggests the state ID has to be one from an open, but that seems to be just a typo. I don't have an answer yet. My impression is that the decision as to when to do directory delegations comes more in the client than the server. But there's obviously going to be cases where the server cares too. The directory being deleted, obviously there's no sense in having a delegation for a directory that doesn't exist. Resource constraints. For the client and maybe also the server, it's kind of cases where you get all sorts of CB notifies, but very few read gears. So it's kind of, it's almost like the ratio between read gears and CB notifies tells you at some point whether it's worth doing this. And a CB recall would get rid of it. That's my impression. On to the next one, I guess. Okay, so now I'm sort of stepping across the fence into the client side. The server was actually relatively straightforward. But as I say, to do all of it, the previous entry as an example, and there was one other, and the rename, it would take a lot more work. I also never looked at ZFS. I don't try going that code, so I don't know if ZFS is relatively easy as well or much more difficult. The trick seems to be to find just the right place in the file system code where you have the information you need, including up-to-date directory attributes. That was the one I had to watch a little bit because the way UFS was, it would usually update the directory and then sometime later it would update the attributes. You really need those updated attributes, particularly for change and modify time. Anyway, for the client, it was definitely more work. The remove is relatively simple. The add is not. The good news is, and I think this is actually almost a feature and not a bug, when you get to the point where it's really difficult to do adds, it basically says you don't want the directory delegation anyway, and you just get rid of it. So the nice thing in the client is if you get to a point where you can't do something easily with it for a callback for the CB notifies, you can just say, forget it, I'm out of here. Return the delegation and stop using it. So, which is a nice feature because without it, you'd bury yourself trying to do all the unusual cases. And since right now, at least on FreeBSD, whenever a directory is modified, it simply ends up throwing away the cache directory information anyway. Throwing it away when you decide that there's just too many CB notifies or they're too difficult to do isn't a big hit. Make sense? Okay, we can wander on to the next one if you'd like.
Yeah, one question.
Sure.
Can you remind us if the in the case of directory delegations, if the callback is required to be blocking for the operation?
Sorry, I didn't get all of that. I heard callback, but I didn't get it all.
So I'm asking if when you when you add a file or remove a file or something like that, whether that is the operation is actually blocked until a notification has been made or not.
Okay,
In
I
other words,
think
yeah.
I think I know what you're asking. The callbacks are asynchronous, which means
Yes.
there's no guarantee when it happens on the server how quickly the client is going to see it. Now,
Right.
I believe I come up to it in a future slide, but basically the client, when it does something that modifies the directory, like removes an entry, it then has to wait until it sees the notify before the directory can be read. Does that roughly answer your question?
Yeah. Yeah.
Okay, so yeah, and I think the asynchronous nature of them is necessary because if you tried to do them synchronously, it would be too big of a performance hit. So maybe we can go on to the next slide.
Uh-huh.
Oh, no, I don't think so. I think we can do it properly.
There we go. Okay, so I have to make sure I know what I'm. Okay, this is really very similar to what I had on the server, except it's per client ID instead of globally. Basically, there's a hash table hashed on file handle and a list of client-side directories. In the case of client, of course, you should only have one per each file handle. And basically, state ID, the file handle, and a couple of flags is about all the information you need. On to the next one.
Yep.
Okay, this gets kind of messy. This is how FreeBSD caches directories. It has two components. That vertical box on the left is a map of cookies to directory buffers. And a buffer is normally an 8K blob broken up into dear block size 512-byte chunks. That's a real bother when you write the algorithms because in FreeBSD at least, the struct dir ent isn't allowed to cross the dir block size boundary. And it makes you work away at it. Each of these blocks is keyed on the cookie of the first entry when it's read in. So you can kind of see the simple example, cookie 0, cookie 17, cookie, I can't even read the print, 20 something and 87. And basically, those are directory entries. Inside each one, there's a bunch of struct dir ents. In FreeBSD without directory delegations, the cookie map has a single entry, the cookie that was used to read that buffer in. The problem I ran into is that when you delete the first entry, the key is still doesn't change, but the first valid cookie to read it from does. So you'll see, I think most of them are the same, and I think one I did make different, the 87 to 91. And the idea there is 87 was removed. It's no longer valid. So the buffer is keyed with cookie 87, but the first valid entry is 91. If you did a read dir with cookie 87, depending on the server, you might get a failure. It happens that in FreeBSD for UFS, it would still work because it'll simply skip over the invalid entries, but that's no guarantee for other servers and read dir as I understand it. So now what has to happen is you have to update these with callback notifies. I think the next slide tries to show that in a little more detail. Yeah. So removing an entry is relatively straightforward. Basically, you look up the buffer using the key, and because you can do less than or equal, you can use the cookie for any directory entry in the buffer and find the buffer. And then you just scan down the buffer for the match. The main trick here is that it's the cookie of the current entry, not the cookie of the next entry. Very similar to the server, I found dealing with the cookie of the next entry was just a PITA. So what I actually do is I stuff the cookie of the current entry in the end of the directory entry. So the struct dir end, of course, the d underscore rec length can be as big as you want. And so I basically hide the cookie of the current entry at the end of it, after the name. So nobody sees it except the NFS code, but it makes it an awful lot easier to find the correct entry than having the cookie of the next one, because it's the same story. The cookie of the next one may be in the previous buffer, and it's very hard to find. So that was just a handy thing. So for removal, it was pretty easy. You just scan down the buffer. Once you have the cookie for the entry, find the match and invalidate it, which in FreeBSD means either extend the D rec length of the entry in front of it or set it invalid if it's the first entry of the dir block size block. And that's done by setting D underscore file node to 0, or you can also send the type to something called white space. So removal is pretty easy. Add, not so much, because to add, you have to first find where it goes. And with the monotonically increasing directory offset cookies, that's not very hard to do. You just search down until you find the spot between if you're putting 25 in, you look for the spot between 23 and 28. But there may not be any space there. So I coded a variety of things to try and make up enough space. One of them is I leave a bunch, there turns generally a bunch of invalid directories entries at the end, because it always fills up the 8K block, and usually a read dir doesn't return enough to fill the whole 8K block. And so that means you can shift the valid stuff down by dir block size 512 bytes and make yourself some space. That's one trick I use. A second one is compaction in either direction. Basically going through the entries from the beginning of the buffer, saying, okay, this D rec length is bigger than it needs to be. Shift everything out, shift the next one up, and shift the next one up, and shift the next one up. And that might make enough space. If that isn't the case, I do the opposite from the end. Shift them down, shift them down, shift them down. If none of that works, I'm at the stage where I say, forget it. This is getting too tough. And I can't add the entry, and I'll just throw away the directory delegation. Because of these invalid blocks at the areas at the end, I usually find a way to get it in. I've probably, for example, test 6 in the Connectathon thing creates 200 entries, and I never fail to find a space to put it in. So it works pretty well, but at some point, I just gave up. It was just too difficult to create new buffers that were already created when the file was read in, because then you start reading from, doing read dirs from the server and overlapping stuff that you have to handle. And I just decided in that case, that's it, man. I've had enough. The directory delegation isn't worth it. So bottom line is, you'll have fun coding it. I'm still not sure I have it 100% correct. And because you can't straddle dir block size boundaries, the actual algorithms get quite interesting. But they're just moving memory around using a version of memcopy that will copy overlapping areas. Like FreeBSD calls it bcopy. Any questions on that? Okay, we'll head on to the next thing. There isn't too much more. Okay, so this is one that related to the question you asked before. When the client does something that's going to modify the directory, like remove, the notify is going to come back from the server sometime, hopefully not too long, but not instantly. So what I do is, for the directory vnode, I hang these lists of, I call them notifies, and basically all they have is remove or add plus the name. one of the things that you can get here is they're not necessarily unique, because somebody could add foo, remove foo, add foo, remove foo, add foo, remove foo. But that doesn't, in the end, really matter, because all the removes and all the adds are indistinct, but you'll get a notify for each one of them. So I just list them all out, and then when the CB notify shows up, I get rid of it, which means when it goes to read the directory, this list has to be empty, or it has to wait till it empties, so that the directory block, this is, sorry, not a read dir against the server. I'm not talking about a read dir against the server. I'm talking about reading the directory in the client from the buffers, because it has to wait for the notifies before the buffers have been updated for the adds and removes, so that the stuff read by the client process will be up to date. Make sense? It's actually relatively simple, and it's just a little weird that the entries are non-unique. But if you've removed foo 3 times, then when you get 3 CB notifies of remove, that should mean that it's safe to copy the buffers to the user process using the read dir system call or get read dirs. Make sense? It's actually get directory entries in FreeBSD as a system call. On to the next one.
You give up waiting at some point and just from the delegation back. So
again, I had trouble hearing that. Sorry, maybe my ears are getting a bit old.
So I'm just asking if at some point do you give up waiting?
Yes, yes,
throw the delegation back at the server.
Yeah, I believe my code currently does, and I would say a production code would definitely want to wait. You're not going to wait forever for a notify, in case the server somehow screwed up or who knows what. And again, the nice thing about the client is you can always throw the directory delegation away. So if you give up on waiting for the CB notifies, at that point you say, that's it, out of the cache, throw away the directory delegation, go back to the ordinary old way of doing things, where you basically read the directory in from the server again. That's really the catch-all and the nice part about the client. You always have this fallback of, I give up, I'm out of here. So anyway, if you like contrived demos that actually show it's useful, I ran a little shell script that removes 20 entries from a directory, reading the directory in between each one. For a small directory, the elapsed time doesn't make much difference. The no ddir is, of course, what FreeBSD does right now. And you can see the number of RPCs for read dir versus the CB notifies, pretty much 6 of one, half dozen the other. But there is a measurable difference, and the CB notifies, if you can do them efficiently, will happen more quickly than the read dirs. For a large directory, it becomes quite apparent that it is useful. Understand, this is not a real application. This is a contrived demo. And it turns out that the Connectathon basic test 6 is a wonderful example of a contrived demo for this, because after it creates the 200 entries, it sits there and removes a single entry, reads the directory, moves a single entry, reads the directory. So it runs 4 times faster with the directory delegations. And in my local little LAN test environment, you couldn't ask for a better example of a case where directory delegations work well. Of course, there's going to be lots of others where they don't. Where you have a directory where some processes are creating a whole bunch of files, but nobody's reading the directory, it's a disaster, put simply, because you just get this great burst of CB notifies and it doesn't gain you anything. The first thing you can do to try and minimize this is at least not get the directory delegation until a read dir happens. which is pretty easy to do. That's one thing, because in a lot of cases, applications create a whole bunch of entries in a directory, but they haven't even done a read dir on the directory. They don't care about the contents. The other case that's much harder to detect is a case where it's a read-only directory. So read dir RPCs happen, but no CB notifies. The good news in that case, the directory delegation does no harm. If there's no CB notifies, it's really no overhead, and it doesn't make any difference one way or the other. But when you get the case where there's quite a few adds and deletes and a few read dirs, it's not a very good situation to be in. I think you can see. I think it's just one more slide that kind of roughly says what I already said. Do you want to go on to the next one? Yeah, so as I say, I'd like to be able to tell you these are the conditions under which directory delegations are a wonderful thing, but except for these contrived demos, I cannot. I really don't have any insight in real environments that might use it. It seems to me that it's primarily a client-side decision, although there's no reason why the server couldn't do this as well. Obviously, a large directory is going to benefit more than a small one. The ratio of the read dirs to the CB notifies is probably a big factor, but unfortunately, you don't know that until you've had the directory delegation for a while. There's no way of doing that one up front. And then the average file name is a factor too, because if it's an environment where they use 250 byte file names all the time, it's going to be a lot harder to do the adds in the buffers. So at least for my implementation, long file names are going to be a disadvantage, because then you have a directory that really doesn't have many entries, even though it looks quite large. Beyond that, I don't have any insight. I don't know if others have thoughts.
So does the protocol allow the server to drop the cookie update? Do you remember that?
If that was a question for me again, I didn't catch it all. If it was just a general statement, fine. or a generic comment.
So I'm asking, does the protocol allow you to allow the server to drop the update of the cookie?
To drop the update? Well, as I understand it, of course, these words were written 10 years ago and no one's ever implemented them, and I'm sure you can find some funny holes in it. My understanding is that when the server has issued a directory delegation to the client, it's committed to doing the CB notifies, but not right away. And in fact, there's even a couple of time limits on it. And if it can't do the CB notify, then at some point it should recall the delegation, is my understanding of it. So I think the answer for you is, if the server can't do the notify, it should recall the delegation, I believe is the correct answer, but don't quote me on that.
So that's not my point.
Oh, okay.
I see a lot of value in getting notified that a file is being added or a file is being removed. I see relatively little value in all this mucking around with trying to update cookies. Because 90% of the time, I don't care. 90% of the time, I really want to know, do I have to go back to the server in the next time round when I'm trying to find out if the directory is the same as before? Because most of the time I'm doing lookups, I'm not doing read dir. So 90% of the time, what I really want to know is, has the directory changed? So having the notifies for the add, the remove, great. Having to force the server to jump through hoops to supply cookie values for them, seemed to be like sort of it was that's over-engineered in the protocol.
Okay, I'm not sure if I got it, what you're asking, but one thing I haven't talked about much is the attributes. I did mention that the server has to be returning up-to-date attributes, and so that way the client tracks change properly. Because if that change isn't tracked properly, then the client's going to say, I have to go back to the server and do a read there. Now, if you're asking about other things like lookups, I haven't done any coding there. The FreeBSD client and FreeBSD in general has a name lookup cache and an attribute cache. And the only things I've done so far is maintained the attribute cache for the directory itself. There is this thing in the directory delegations about child attributes. I haven't touched them. And in FreeBSD, on the server side, it wouldn't be very useful or meaningful because the attributes that change are far enough disconnected from the directory that I don't think they're meaningful. As for the lookup name cache, the adds and deletes should probably go into it. What tends to happen there is the name cache gets invalidated when it sees a change to the directory. But obviously there's an optimization there that if the client can apply the adds and removes to the name cache, and then it can say, okay, now it's still up to date and you don't need to invalidate it because of the change attribute changing, then the client could benefit from that. That's definitely something you'd want to, if I was ever taking the FreeBSD implementation to a production stage, that's definitely something I would want to do. But I have not done that as yet. I think that's when most of the game in terms of caching is going to be. It's going to be sort of being able to more reliably decide when you absolutely have to go to the server in order to revalidate your lookup cache. Yes, I would agree. And lookups are so predominant. If you can get the name caching in the client using directory delegations to remain up to date so it doesn't have to do lookups, that would be a big gain in the client, I think. Yes.
Okay, I think I see what you mean. So like, we wouldn't use these for read. So if someone does a reader, you go to the server. Yeah, but for lookups, then we can do that. That makes a lot of sense, I think.
So making the whole cookie thing optional, that would be, you know, if it isn't already, then that would be a big improvement, I think.
Yeah, you're right. I think.
Is that a protocol change?
I don't know. I've looked at the protocol recently.
I'm looking at it now. Yeah, there are places in there where you, like, if you do a notify add for, it's got, you know, previous and next cookie entries, you know, and stuff. So, or previous, it's got a new entry cookie, so that you have to know what the cookie is to send it back in. Yeah. But maybe we just, you know, can do an addendum to the spec and say, just say you can always send 0 here. It should be right. You know, so that makes a lot of sense, I think.
I'm not going to tell you the cookie. I've got it, but you don't. You can't find it. Good.
Well, because I think that would lower the barrier for implementation considerably.
Yeah, we could work with that, I think, because we could just slot something into the thing, and then whenever someone does a reader on the directory, you could just go ahead and say, okay, we're going to blow away the cache. Yeah, so
That makes a ton of sense, especially when you have Ranger Plus in the mix. I mean, you've got all this other crap to worry about. You know, it's just easier to just say, give me the current stuff.
Yes, I think it is a good point that you could use directory delegations related to client-side name caching and lookup, and that would be almost a separate area, and might be more beneficial than trying to maintain the cached blocks that a read dear reply is translated into and then passed on to userland. But I haven't looked at that one, and I think that one is an interesting one. I might dig into the code and see what I can do.
Yeah, I like it. It sounds like a big win.
Yeah.
A hell of a lot less work than caching all that other stuff.
Right.
Yeah.
Stuff this scale for years. That big of a directory. You know.
Are smart.
Yeah.
I don't know.
All right.
Thanks, Rick.
Thank you.
Cool.
Yeah,
That's
yeah,
cool.
very cool.
Well done, Rick.
Yeah.
Okay.
Yeah.
I hope you found it somewhat useful, and feel free to continue to discuss it. If other implementations start to crop up, or if someday I get a little farther down the road and do the lookup name caching, maybe we can discuss it some more. I think they are potentially useful, but it's hard to say. And it's certainly not a trivial exercise implementing it, although it wasn't a really big exercise. And it is kind of fun. Anyway, I hope you found the talk somewhat useful.
Yes.
Yeah, it's something we've been kind of considering looking at. We haven't gotten started on Linux yet, so very cool. Yeah.
Okay. All right,
Thank you.
then.
Cool. Thanks.
Thank you. Yep.
So I guess we could just hook it up to FA Notify, right? I mean, pretty much just you know, set notification watches on the directories we've given out those delegations, and when they come in, you send off a CV Notify, right?
But is FA Notify reliable? I thought it would.
It's reliable enough in terms.
Yeah. Enough.
The internal stuff is, yeah, I mean, FA Notify, well, we probably wouldn't use FA Notify. We use the notification infrastructure in the kernel.
Right.
You know,
We're already using it for the file cache.
we're already using it, right? Yeah, we would set.
It is supposed to be reliable, and you have notification in it. APIs at this point that allow you to rely on it. You basically pipe-based notification mechanisms that sort of queue up everything.
One of the things I'm not sure of though is like when you get a notified add entry, what attributes do you get? Because
So
do we need the inode number?
yeah, fair enough. You need the inode number
In the type.
and possibly the type.
I mean, you need to be able to set an inode, right? So
I don't care so much even there,
okay.
because what I really want to know is, am I wasting my time by sending a lookup?
Oh,
Okay.
yeah.
So we can set some sort of like stub entry or something that says, okay.
Because right now, what happens is if I see the change attributes on the directory changing, I basically have to say I'm invalidating my entire
Right.
lookup cache.
Yep.
And I'm going to have to revalidate every single one of those entries.
Yes.
And even though I keep the entries around so that once I've revalidated them, I don't have to sort of rebuild the entire structure that existed. I'm still having to go do a lookup for every entry, and it would be a huge win, especially for large directories, if I did not have to do that.
I see. So you're just saying like, but if someone does a lookup on this new entry that we got a notification for, we would just go to the server anyway.
Yeah.
But it's more just a.
It's
So the actual entry, the actual info we get is somewhat superfluous actually from the server, right? We don't really need to know what the name of the entry is or anything, right?
Right. Well, for the remove side.
Yes, you do need to.
It's nice to have.
Okay,
have a name as well, so you throw out the entry,
But on the ad side, you could probably just ignore a lot of the info that's in there.
Yeah,
You just say,
Yeah, I mean, what you really care about is, oh, has done to change? Yes.
Yeah, there's a change attribute change, or yes, attributes have changed, but now we know that, but you don't necessarily know what the new new entry is. You're just not going to serve that. Okay, that'll probably work.
Good. All right.
I like it. Cool.
Take
Thanks,
care.
Conrad.
Thank you. We're switching over to the other side, the other one, the other link.
Okay, well, bye then.
Yeah.
Thanks,
All right,
Steve,
perfect.
for making it work, because I would have never gotten that stupid.
No, that was
display
Ben's
thing to go.
job. That's Ben. Ben's all on him. You got it working. Thank you. You're welcome.
Okay,
Cheers.
bye then.
And that's true. Thank you very much.
Yeah, I'm just clicking on stuff.
Yeah, you are good. Okay, we're good. Thank you very much.
I need to take a little power nap.
My back too.
I'm gonna go sneak out for a minute. I'll be right back.
Yeah, I'm gonna go get some liquor.